All right, this is Algebra 1. And let's go to page 141 in your book. All right, I believe that we've talked about like terms before. Like terms, yeah, it's back on page 97. Like terms are, I know this might sound like it's maybe stupid, but for lack of a better way to say it, they are terms that have the same part. Let's say, I was going to say like, they are terms that are like, but how about if we say it this way? They are terms that have like parts. For example, 3x and negative 4x. Those would be like terms because they both have x on them. How about 4y and negative 7y? Those are like terms because they both have y's on them. How about this one? 3x squared and 4x. Those would not be like terms because the parts aren't exactly the same. The x's aren't exactly the same. And then you have also constants like 35 and negative 22. Those would be like terms because then we could either add or subtract them. So like terms are important. Also, we have input, output, and this is back to the functions. Okay, and I think about a table, like an XY table. Remember, the inputs are the x's, the outputs are the y's. What do we do to x to get y? So there's input, output, and let's see what happens here as we solve some two-step equations. This is called a two-step equation because it involves there's basically two operations performed on x. It is being divided by 2 right here. If I can get my pen to work, it's being divided by 2 right here, and there's a 5 being added to it. If you guys will look, there's a box on page 141 in your book. There's a box that's kind of got a green heading. It says operations performed on x. It's being divided by 2, and then it's adding 5. So to do the inverse operations, your operations to isolate x, you need to do the inverse. So you need to get rid of the 5 first, then get rid of the 2. So let me erase what I just put on there. And I always remember that if it's two-step, I always get rid of what's added or subtracted first. And if you remember, whatever you do to one side of an equation, you have to do the same thing. So the opposite of adding 5 is subtracting 5. So those are going to cancel out, and you get x divided by 2 equals 11 minus 5, which is 6. And then I always say things out loud because I can hear the inverse better if I say them out loud. So, and you might say, yeah, you have to say them out loud because you have to teach it to us. But I want you guys to do the same thing. Because a lot of time when kids ask me for help, I'll come over and all I'll do is read it out loud to them and they'll go, oh, now I know what to do. So practice doing that yourself. So this is x divided by 2. The opposite of dividing by 2, or the inverse of dividing by 2, is to multiply by 2. Because remember, what we want to do is get rid of whatever is with the letter by doing the opposite. So then 6 times 2 would be 12. So let's check our work. 12 divided by 2 plus 5. Well, 12 divided by 2 is 6. And 6 plus 5 is 11. So that one works out. Excellent. Let's see what they do. Notice, always, always, always write the original equation when we're dealing with our algebra here. So they minus 5 from both sides. It's hard for you to see. X divided by 2 right there. They multiply each side by 2 just like we did. And x comes out to be 12. Okay, and then it says to check it, which is what we did. We substituted the value into the original equation. We did 12 divided by 2 and got 6, and then 6 plus 5 is 11. Okay, so here we go. Here's a two-step equation. There's two things attached to this. 5 times x plus 9. I always say it out loud. We always get rid of what's added or subtracted first. So what's the opposite of adding 9? You would subtract 9, and you would do that to both sides. Whoa, I got some pin problems here. Just a second. Let's go forward here. Sorry. Ooh, it's going to act up on me tonight here. So my 9's cancel out. I bring down what's left because I haven't done anything to that. I haven't done any inverse stuff over here yet with the 5. 24 minus 9 is 15. And then I said out loud 5 times x, the opposite of timesing by 5 would be to divide by 5. So x in this case equals 3. So let's check it out. 5 times 3 plus 9 is supposed to be 24. Well, 5 times 3 is 15 plus 9, and that is 24. So it works out. It checks. So x should be 24. Let's see what there. Or excuse me, x is 3. The check was 24. So the answer is 3. X equaled 3. Okay, that's 4 times y minus 4. So we all remember, a lot of times kids will say, well, how do you know what side to start with? You always start with the letter. Our job is to get this y by itself. So the first thing I'm going to do is get rid of that 4 by adding 4. And I do that to both sides. Those cancel out. I bring down what's left. 16 plus 4 is 20. I divide both sides by 4. Y in this case equals 5. So check it. 4 times 5 minus 4 is supposed to be 16. 4 times 5 is 20 minus 4, and that is 16. So it checks. So y equaled 5. You can't see it very good, but it's there. Y equaled 5. Okay, now this, they're kind of messing with us a little bit. Notice they put the z on the right hand side. It's if you want to rewrite it and put it over here like this, that's totally okay to do that. We're not doing anything to it. We're not changing any signs or doing anything. If you don't like the letter on the right, I would just say get used to it. You're going to see it a lot of different ways. So just get used to it. You know, you're trying to get the z by itself. So we're dealing on this side now. So we have a minus 7. So we would add 7. And they try to throw it and those cancel out. So I get z divided by 3 over here. I don't like the z's. I think they look like 2's. Over here you have to be careful. Look at this is a negative 1 right here. Negative 1 plus 7 is positive 6. So I have to be careful there. And then we're still getting the z by itself. Z divided by 3. The opposite of dividing by 3 is to multiply by 3. So my 3's cancel out. Z equals 18. Let's check it out. 18 divided by 3 minus 7 is supposed to be negative 1. 18 divided by 3 is 6 minus 7 is negative 1. So it works. Notice, you're starting, I want to see all this on your guided practice. I don't want you to just put z equals 18. I want you to practice this work with me. If you don't understand how to write it out, let me know because I'm going to look for it on your work. I want to see every one of these steps. The answer is 18. That's what we came up with. Okay, example number 2. It says solving a two-step equation by combining like terms. So the first thing you do before you solve for x is you try to make sure both sides are simplified. There's nothing you can do to 21. 21 is already as simplified as it you can go. But look at this, 7x minus 4x. We can subtract that because those are like terms. What is 7x minus 4x? It is 3x. That equals 21. Then you might say, wait a minute, how come I don't add 4x to both sides? Remember, you don't want to be moving x's around. You want to simplify things before you solve for the x. So you look for like terms that you can combine. So now this is 3. That was the first step, was combining the like terms. 3 times x, so the opposite of timesing by 3 would be to divide by 3. And you do that on both sides. And x in that case equals 7. So let's check it out. 7 times 7 minus 4 times 7. Sorry, my pen is not wanting to cooperate. 7 times 7 is 49, minus 4 times 7, which is 28, and that is 21. Works out good. We're done. Okay, so we're looking for combining those like terms, and we'll do some more of those in the guided practice here in just a second. And here they're writing the original equation. There's those like terms, dividing both sides by 3, and coming up with x equals 7. All right, so here's the input-output stuff. Example number 3 says the output of a function is 3 less than 5 times the input. Remember, the input is x right here. Okay, the input is x, so 5 times the input would be 5x, and 3 less than that would be minus 3. Find the input when the output is 17. So we want to find out what is x when we get 17. So here's our two-step equation. We get rid of the 3 first by adding 3 to both sides. Those cancel out. Bring down 5x equals 20. Divide by 5. Divide by 5. X equals 4. There's algebra. You too can write those problems as fast as me. Just practice and you guys will get it. 5 times 4 minus 3 is supposed to be 17. And 20 minus 3 is 17. So there's our input. when we have an input of 4, our output is 17. So that means when x is 4, the answer is 17. Or we could say y is 17 because of a lot of times it works out that way. So let's check out how they did it. There's their equation, and they got 17. Checking it. I guess I didn't check it. Oh, I guess, sorry, they're solving it. And x equals 4. Same thing. Oh, sorry, now they're checking it. Putting the 4 in for the x, we did this. And 17 equals 17. All right, so check this one out. Here are our like terms, our 4w and our 2w. Together make 6w. That equals 24. And then we say 6, our job is to get w by itself. 6 times w. The opposite of timesing by 6 would be to divide by 6. And in this case, w equals 4. Let's try it. 4 times 4 plus 2 times 4 is supposed to be 24. So that's going to be 16 plus 8, which is 24. And it works. W equals 4. Okay, again, like terms, 8t minus 3t right here. 8 minus 3 because their t's are like, 5t equals 35. 5 times t, so the opposite is to divide. So t in this case equals 7. So 8 times 7 minus 3 times 7 is supposed to equal 35. 8 times 7 is 56 minus 21. Let's put the 21 underneath there and see if we get 35. Yep, works out. The answer is 7. Ooh, check this out. They're messing with us a little bit. Over here's our d's. These are like terms. 5d minus 9d. I think that's unfriendly, so I'm going to boom boom it. So 5, I can add these because they both have d's on them. 5 plus negative 9 is negative 4d equals negative 16. Negative 4 times d, the opposite of timesing by negative 4, is to divide by negative 4. Those cancel out. d equals positive 4. So we have 5 times 4 minus 9 times 4. So 20 minus 36 is negative 16. If we boom boom that, we would subtract it negative 16. So in that one you have to be really careful of the signs. A lot of times kids miss because they forget to deal with the signs. And a lot of them say, oh, all I did was forget a sign, but it will mess up the whole problem. And they agree with us, it's 4. For the input-output, the output of a function is 5 more than negative 2 times the input. Remember, the input is x, so negative 2 times the input and 5 more than that. Find the input when the output equals 11. A lot of this is writing, remember when we did them in words and we wrote them out? 2 times the input and 5 more than that. So this is a 2-step equation. There's our plus 5. Let's get rid of that first. So we minus 5 from both sides, bring down the negative 2x. That equals 6. Divide by negative 2. And x in this case equals negative 3. Let's try it. Negative 2 times negative 3 plus 5 is 11. Negative 2 times negative 3 is positive 6 plus 5 is 11. And x is negative 3. Okay, number 8. The output of a function is 4 less than 4 times the input. So again, 4 times the input would be 4x. 4 less than that would be minus 4. Find the input when the output is 3. So I'm going to add 4 to this side, add 4 to this side, cancel it. 4x equals 7, and divide both sides by 4, 1 and 3/4. And don't run for a calculator, just simplify your fractions. You could even leave it 7/4 if you'd like. 1 3/4. Okay, the last example before we start to go here a little bit is scuba diving. As a scuba diver descends into deeper water, that means go down, the pressure of the water on the diver's body steadily increases. The pressure at the surface of the water is 2,117 pounds per square foot. The pressure increases at a rate of 64 pounds per square foot for each foot the diver descends. Find the depth at which the diver experiences a pressure of 8,517 pounds of pressure per square feet. So we're adding pressure as he goes down. We're adding 64 pounds of pressure as he goes down to the already 2,017 pounds that he had. So we have 2,117 plus 64 times every foot. So I don't know if they tell us what letter to use. For every foot that goes down, and we need that to equal 8,517. I think that's, let's see what they come up with. They're probably going to write a verbal, they're going to write a verbal model. The pressure plus the rate of pressure, and then the diver's depth and feet. They just use D, I used F. Same thing. So then to solve it, there's our equation. So it's a two-step equation. There it is. So we're going to get rid of this. We have two things attached to the letter. We're going to get rid of this. We're going to subtract 2,117 from both sides. Here, I'll let them do that. It's going to get kind of big. There they are. We get 64. Oh, that's going to be easy to divide. It'll be 100. So the diver after 100 feet would experience 8,517 pounds of pressure per square feet. And then you can substitute that number in, multiply it, and see if it comes out to be 8,517, and it does. Okay? So what if the diver experiences a pressure of 5,317 feet per square foot? Find the diver's depth. So we're using that same equation, 2,117 plus 64D this time has to equal 5,317. So we solve it the exact same way. We subtract 2,117, 0, 0, 2, 3 equals 64D. Divide by 64. Those canceled out. That's where that 64D came from. And I don't know how many times 64 goes into 64 times 5 is 0, carry the 2. Look at that, 32. 50. Oh, I bet you that's half of where I should have noticed that was half. 50 feet. Okay, Kim has a job where she makes $8 per hour plus tips. Kim made $53, 13 of which was from tips. How many hours did she work? So 8 hours, 8, we don't know how many hours, plus her number of tips equals, this is hours worked, this is tips, equals her total pay. Okay, so we don't know how many hours she worked, so it's 8x. We know she made $13 in tips, and we know she made a total of $53. So we're going to minus 13. I get 40 equals 8x, divide by 8. X in this case equals 5. So Kim worked for 5 hours to get her pay. 5 hours. Oh, and you should always label, especially since it's a story problem, label your answer. All right, that's it. Two-step equations. Remember, show your work, just like the way we practiced it on the guided practice. If you're not sure, please ask so you don't miss any on your assignment. See you next time.